Hi everyone, welcome to LFI Educates once again. Let us go in continuation with our classical theory. In our classical theory, we have gone through the derivations of drift velocity in relation to electric current and drift velocity, the mobility we have come across. Then we have deduced Ohm's law as well. Now, while deducing Ohm's law, resistance, we got an expression like this: resistance is equal to ml divided by n e square a tau. This was the expression for resistance. We have replaced this term with resistance R in our classical theory. Now let us see about the expression for resistivity of various metals. Earlier we have seen that resistivity rho is equal to R times A by L. So if you put the value of resistance here, resistivity is equal to ml divided by n e square a tau into A by L. We'll find the expression for resistivity, that is m divided by n is square tau. So the letters is familiar to you, I think. M is the mass of electron, n is the number of electrons per unit volume, or we call it as number density of electrons, free electrons. E is the charge of each electron, tau the relaxation, average relaxation time. From here what we find out is we get the expression of resistivity according to our classical theory, as well as we come to know two things. Resistivity is inversely proportional to the number density of free electrons. If the number density of free electron is more, resistivity will be less. And if the number density of free electron is less, then the resistivity will be more. And secondly, we come to know about resistivity depends upon the average relaxation time as well. This is also dependent, they also depend inversely. So these two things we come to know. Now we'll learn about conductance. It is just the opposite of resistance. Conductance we write it as G. Resistance is the capability to offer or to oppose the flow of current. Conductance is just the opposite of that. It allows the flow of electric current. It can be defined like this. Conductance G is the reciprocal of resistance 1 by R. Its SI unit is mho, OHM for resistance, here MHO, mho. We write it as power omega like this, or SIEMEN, Siemen. We write it as capital letter S as well. The other term that you have to know, opposite of resistivity, that is conductivity. Conductivity we represent with the symbol sigma, and conductivity is defined as the reciprocal of resistivity, that is 1 by rho, and its SI unit is mho per meter. Per meter. And symbolically we write like this: mho per meter, or Siemen per meter. Symbolically Siemen per meter you can write like this, or you can put one slash, then power will be 1. You can write like this: Siemen parameter as well. Relation between current density J, conductivity sigma, and electric field E. The relation between these three, we call it as microscopic form of Ohm's law. We call it as microscopic form of Ohm's law. Let us see the relation. We know that current I is equal to NEA VD. This is the relation between electric current and drift velocity. Electric current I can also be written as EA VD. Our expression for drift velocity is EE tau divided by M. So it will become N, E into E will become E square AE tau divided by M. This A, if I bring down, left hand side we have current I. A, if I bring down, you get the expression for current density. This is N E square A tau divided by M. Sorry, A you brought it down, it will be E. Now this I by A we call it as current density according to the definition of current density. Here N E square tau divided by M into E. Like this you can write down. Here since I by A or J we wrote for I by A, then J is equal to, this is the expression, the reverse expression of resistivity, 1 by rho into E. Since rho is equal to M, N is square tau. This is the expression for resistivity. Now this J, the reciprocal of resistivity, we call it as sigma, the conductivity, into E. So current density J is equal to conductivity sigma multiplied by electric field, applied electric field. This relation we call it as microscopic form of Ohm's law. So here we end up our classical theory of electricity, the origin of resistivity. Let us study now color code for carbon resistors. In most of the electronic and electrical devices, we use resistors of different capacities. So a carbon resistor looks somewhat like this. It's very small, it is of this order. There you can see some color bands are present on the resistor. It is somewhat cylindrical, like this. There will be two terminals. Then some stripes you can see there. Sometimes 3, sometimes 4 stripes you can see. If it is 4, the fourth one will go a little bit far. Its gapping will be more. These are made up of colors. This is green, suppose. This is red. This is orange. And this is suppose gold. Like this it will appear. Now by looking at this color, you should be able to write down its resistance, or we should know how much resistance the particular resistor will offer. To know this, we study this topic called color code for carbon resistors. To understand this, if you can remember this sentence, it will become very easy for you. I'll write down here black, brown rods of your gate become very good when given silver color. If you look at these words, you can see all the words that I have used. I started with block letters. These are the letters that you are going to pick up from here. The first letters from each word. Like this, you have to remember color first of all. First two you can see black, brown. Then the next color, rod means R, red. Off means orange. Your means yellow. Gate indicates green. Become, that is blue. Very good, V is violet. Good, G, that is gray. There are two G you can see. One is green, one is gray. And 3B, black, brown. The two will not get confused, but this blue, B is blue. After that gray, then when given silver color. When indicates, W indicates white. G indicates gold. Silver is silver itself. And color indicates no color. Colorless. Or we can say that band is absent. This fourth band is absent. So the next column, I write down the numbers or the digits that we use for black. 0, it starts from 0, 1, 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9, then gold, silver and no color does not have any digits. Then in the third column, we'll write down the multipliers. Multipliers, it will start with 10 to the power 0, 10 to the power 1, look here 0, 10 power 0, 1, 10 power 1, 2, then 10 power 2, 3, then 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8, 10 power 9, 10 power minus 1 and 10 power minus 2. For no color again, nothing you have multiplier. Then the fourth column will give you the tolerance. For tolerance, for the first 10 digits 0 to 9, they don't show any tolerance, but the last 3, gold, silver and no color, you have the tolerance factor. Gold indicates around 5% tolerance, 10% tolerance, that is for silver, and no color is around 20% tolerance. So this way you can get the table if you know the sentence. Now, if you get a carbon resistor like this, as I have given you the example earlier, now I want to know its resistance, then how to use the table. Look carefully. The first color is green. So the resistance R is equal to, I'll write green. Green is here. Digit is how much? 5. So I'll write 5. Then next band, what color it has? Red. Red is 2. So I'll write 2. The first two color will give you the digits. This one, first two bands will give you the digits. Then the third band, there is orange. Orange, there is a third color, so we have to go to multiplier. That is 10 power 3. Into, you will do multiplier 10 power 3. And that is the way to write down the resistance. We will write ohm. Then plus or minus the tolerance. We will write down the last band, it is gold. So gold tolerance is how much? Is 5%. So I will write 5%. This way you can get the resistance of the particular carbon resistor. Sometimes you may get questions like this: how will you represent a resistance of 3700 ohm plus or minus 10% by color code? So to solve this, you have to write down the given resistance R is equal to 37 into 10 power 2. Like this, first two digits you write, the third one will be your multiplier. 10 power here it is 2 ohm plus or minus 10%. After writing this, then you can refer to your table. 37, first two digit, first band, it will be, the colors will be 3 is orange, then next one is 7. 7 is for violet. The first band orange, the second band is violet, first band orange, the second band violet, then the third one is a multiplier 10 power 2. You can see here it is 10 power 2, it is red. The third band is red, and the last one, that is your plus minus 10%, that is tolerance, that is your silver color. So the fourth band is silver. So like this you can write down the colors for each band in the carbon resistor. The sequence of colored bands in two carbon resistors R1 and R2 is given here: brown, green, blue, and orange, black, green. You have to find the ratio of their resistances. So first of all, let us write for the first one as R1. The resistance is R1. Brown, green. Brown, green. It is 1 and 5, 15. 15. Multiplied by third one, that is blue. Blue here you will find 6. Multiplied is 10 power 6. 10 power 6. And fourth band is not there, that means no color. You write it as, this one you write it as ohm, plus or minus 20%. The second one, R2, orange, black, green. Orange, then you have black. Orange is 3, black is 0. 3, 0 into green. Green, the multiplier is 10 power 5. 10 power 5 ohm, plus or minus, here also no color, there is no color, so 20%. Like this you'll find out their individual resistances. And after that, to find out their ratio, therefore R1 by R2 is equal to 15 into 10 to the power 6 ohm divided by R2 is 13 10 to the power 5 ohm. Well, find the ratio, we will not write the tolerance. Ohm will get cancelled. 15 2s are 30. And here you have 10 power 5. If you cancel it, you will have 110. That is 10 by 2. If you cancel it, you will get 5. So the ratio of the resistances, we write like this: R1 is to R2 is equal to 5 is to 1. Downside nothing means it is 1. So likewise you can find out the ratio. Let us do a numerical here related to conductivity and conductance. A wire carries a current of 0.5 ampere. Current I is equal to 0.5 ampere. When a potential difference of 1.5 volt is applied, potential is 1.5 volt. What is its conductance? We are asked to find out the conductance G. If the wire is of length 3 meter, the length of the wire is 3 meter, and area of cross section, it is 5.4 millimeters square. This is not an SI unit, so we'll make it in meter square. 5.4, 1 millimeter will be into 10 to the power minus 3. You have 2 times, square is there, so I'll write into 10 to the power minus 3 to become meter square. So ultimately it will be 5.4 into 10 to the power minus 6 meter square. Now let us see what to find. What is its conductance? You know the formula of conductance. G is equal to reciprocal of resistance. Is reciprocal of resistance. Resistance here is not given. So what we have to do is, using Ohm's law, we can find out the resistance. We know that R is equal to V by I. V is 1.5 volt. Current is 0.5 ampere. Decimal 1 digit you can cancel it. 5 3s are 15. So it will become 3 ohm. Then you can find out the conductance. Therefore, conductance G is equal to 1 by R. 1 by R is 3. It will be mho or per ohm, like this, right? Then we divide it. 3 3s are 9. 1 you cannot divide by 3. First of all, decimal will put. 3 3s are 9. 3 3 3 will go on per ohm. Like this you can find out the conductance. The next one, if the wire is of length 3 meter, then what will be its conductivity? Conductivity, as you know, conductivity we write it as sigma. It is reciprocal of resistivity, and resistivity is equal to R times A by L. So ultimately it will become L by R into A. Then we put the value L, that is 3 meter, resistance R, that is 3 ohm, into area of cross section. This is 5.4 into 5.4 into 10 to the power minus 6 meters square. 3 can cancel 1 time. This 10 power 6 minus will become plus power, divided by 54. If you write again into 10 will come. Divide it. Here nothing means 1. You can make from here, you can take 10, cannot divide by 54, so make it 100 into 10 to the power 100. If you take from here, it will remain 5 power divided by 54. 100 divided by 54. 1 times 54. 640 decimal 54 5 8s are 40 5 9 times 9 4s are 9 5s are 45. No, 9 will not come. 8 4s are 32. 3 in hand. 8 5s are 43. So it will be 1.8 into 10 to the power 5. Then Siemens per meter. You can write on the unit per ohm per meter or Siemens per meter. Like this you can calculate the conductivity. Thank you and have a nice day. Stay tuned with LFI Educates till the next video comes.